Hello everyone, Paul here from Fixing Foundations with another college algebra tutorial. Today we will be talking about scientific notation. Now in a previous video we talked a little bit about exponents and how they are a way of speeding up multiplication. So here you can see that we have a base of 3 and we are raising that to the 4th power. And when we do that, it means that we are going to multiply 3 by itself. You can see that we have 1, 2, 3, 4. We have written 3 4 times in this expression here after we have simplified the exponent, and then that finally becomes 81 when the multiplication process is complete. And we can do something similar with a base of 10. And you can see here when we take 10 and we raise it to the power of 5, we will multiply 10 by itself and it will appear 1, 2, 3, 4, 5 times. And interestingly enough, you can also see that we have 1, 2, 3, 4, 5 zeros that appear in the digit columns after we do this. So moving on, we can multiply coefficients by bases of 10 as a way of describing larger numbers, and this process is known as scientific notation. So for my first example here, you can see that we have 8. We multiply it by 10, but not just 10 by itself. It's 10 being raised to the 3rd power, and you see that we get 8,000. And here too, we also see that we have 1, 2, 3 zeros. This matches the exponent that we have here. And we have another example here. We have 5 multiplied by 10 to the 7th power. And this becomes 50 million. And this has a total number of 1, 2, 3, 4, 5, 6, 7 zeros in the digit columns, which also matches our exponent here. And you may see this and you might think that converting numbers that appear in scientific notation is as simple as just adding zeros to the end of it. But this isn't necessarily the best way of thinking about it. And the reason for this is because quite often decimal points will appear in the coefficients when using scientific notation. So you can see here that we have 3.74. It's being multiplied by 10 to the 6th power. And we actually only have 1, 2, 3, 4 zeros in the digit columns, which does not necessarily match up with the 6 that we have here. And what exactly happened? Well, to write it down here, I'm going to write 3.74. I'm going to multiply this by 10 raised to the 6th power. And instead of thinking about this as adding zeros to the digit columns, what I'm going to do is I'm going to take 3.74 and I'm going to look at this decimal here and I'm going to move it 6 jumps to the right. So I'm going to count 1, 2, 3, 4, 5, 6. So that's just to check 1, 2, 3, 4, 5, 6 jumps to the right. I am going to fill in a 0 for every jump that has nothing in the digit columns. And you can see after I clear up what I've written here, after I clear up these jumps, and I put the appropriate commas, that we have gotten the correct answer. We have ended up with 3,740,000 as our final answer. So when you are converting numbers that appear in scientific notation, I encourage you to think about it in this way, as decimal jumps rather than adding zeros to the end of the coefficients. I want to give you a couple more examples before I end this video. So let's say we had 4.65 multiplied by 10 to the 7th power. This would be something like, I'll write 4.65 here, and I'm going to do 1, 2, 3, 4, 5, 6, 7 jumps, and then I'm going to fill in a 0 for each empty decimal column. And finally, I am going to erase what I have done in terms of the jumps and the decimal point, and I'm going to just put in commas, and we end up with 46,500,000 as our final answer. And sometimes when you're working with scientific notation, you do the reverse process, so numbers will appear in standard form and you will convert them to scientific notation. So let's say we had something like that. Say we had 845,000. And we wanted to convert this into scientific notation. Well, what we would want to do is we would write the same number, so 845,000. We would put the decimal point here. So scientific notation, it's always important to point out that the coefficient is always going to be equal to or greater than 1, but it will always be less than 10. So you want to stop somewhere around here. So you wouldn't want to put it, say, I'll show you what would be incorrect. You would not want to put it somewhere here, and you wouldn't want to put it somewhere here. It's very important that you place it in a way so that the coefficient that appears is greater than or equal to 1 but less than 10. So we have 8.45 here, ignoring the zeros, and this is less than 10, but it is also greater than 1. Now, as far as converting this to scientific notation goes, we're going to do a similar process. Let's actually just erase the decimal point for a moment. So this was the original number, and this is where the decimal point would be, because we don't really have any decimal values, so it would be at the end here. And we're going to move this in a way so that we will create a coefficient that is greater than or equal to 1, but less than 10. So we'll do a jump here, we'll do another jump here, jump here, jump here, finally one more jump. Then we'll see how many jumps we've made. We've made 1, 2, 3, 4, 5 jumps total. And this is where our decimal point is going to fall. So we have 5 jumps, and we are going to create a base of 10. We're going to multiply what we have by a base of 10, and we are going to make 5 the exponent, because that is the total number of jumps that we've used. So I'll erase what we've written. I'll erase these zeros here in the decimal columns because those are extraneous. And I'm going to move this down. And you can see here that 845,000 becomes 8.45 times 10 to the 5th power. And just to confirm I did that correctly, I'm just going to put that in the calculator and just make sure that it is correct. This is a good way to check it if you have access to a calculator. And you can see that these two expressions are equal. That this is equal to this. And hopefully you understand the concept of scientific notation at least a little better. Thank you very much for watching this video. If you are interested in seeing more tutorials for college algebra, I encourage you to subscribe to my YouTube channel. And if you are interested in having a tutoring session with me, you can feel free to send an email to the email address that you see on screen. That is fixingfoundationsfoundation@gmail.com. Thanks again for watching.